we're going to rationalize denominators. The rule is that a fraction's denominator may not contain a root, like a square root or a third root. Here are the types of things not acceptable. 1 over square root of 2, square root of 5 over square root of 7, and this is not what matters. It's the square root of 7 that matters. Square root of 6x, 3 minus square root of 5. Through the course of this, we are going to do each one of those and some others. What we do to rationalize is you multiply by the number 1, but in a form that helps you. In other words, you take the square root in the bottom and multiply it by itself, but you have to make it both top and bottom in order for it to be a 1. Because when you multiply by 1, you don't really change it. You just make it look different, but it's still the same number. 1 times square root of 2 on top. On the bottom, square root of 2 times square root of 2 is the square root of 4, which is 2. Actually, I wrote it down here because I was going to say the point is to make this multiply by 1 in that form. So that's the idea of what you're doing. You multiply by 1, but in something that's useful to you, in this case square root of 2. So this would be an acceptable answer. So when we look at this one, we're going to do the same thing. We're going to multiply by the square root of 7 over the square root of 7, because that's what we need is for this one to make a 7, and that's because this is equal to the number 1. So let's do it down here, and I'll actually, write the whole thing. That becomes the square root of 35 over 7, and you can't do anything more because the square root of 35 is actually just a little bit under 6. That's about 5 point something. So even though there's a 7 inside that, it's not a 7 squared that's inside it, so you can't cancel anything with that. So that would be the acceptable answer for this. And in this case and in this case, all we really did is we took the square root on the bottom, moved it up top, but by doing it top and bottom, we were able to make it a non-square root on the bottom. So here, we're going to do a couple of other variations to it. In this case, with the square root of 12, there are two things we can do. We can multiply by the square root of 12 over square root of 12, but we first also could have done this, where we're going to simplify the bottom. We have 1 over 2 square root of 3. So here in this case, the square root of 12 is actually 2 square root of 3, which means we only have to use square root of 3 over square root of 3, which gives us square root of 3 over 2 times 3, square root of 3 over 6. It would have been legal and acceptable to have done it with square root of 12 over square root of 12, but then we would have had more canceling out to do when we got to the end. So here in this case, we will use this one to do it in numerous ways. There are 3 different ways that this one can be looked at. Okay? So one of the things we can do, and the simplest one is in this case, let's first partially simplify it. Square root of 18 can be seen as square root of 6 times 3. That can be broken into 2 of them. These 2 cancel out, so we have 1 over square root of 3. And then we do the normal rationalization of the square root of 3 on top and bottom. Now, if you aren't sure about breaking up, you could do it in a different way or not recognize that and do it this way. Okay. Let's see, if I recognize that that's 9 times 2, I would have square root of 9, square root of 2, that's a 3. Square root of 6 over 3 root 2. Then I would rationalize with the square root of 2 over square root of 2. And that would give me square root of 12 over, this is a 2 times 3, that's, these 2 make 2, so we have a 6. Square root of 12 is a square root of 4 times 3, so that's actually 2 root 3 over 6. Ah, look at it, it becomes square root of 3 over 3, just like the one that's up here. Another way to do it, if you don't even break it at all, is to be willing to use larger numbers, although it doesn't have to be that much larger. Oops. Let's multiply by the entire square root of 18. So if I do that now, I'm going to get, this is going to be 60, 40, 100, 108, I think. So it could go that far. In fact, actually one way to do this, to make this a little easier, is to just break these down to all of their parts inside it. So 18 would be 3 times 3 times 2. All right, yes, I think so. So we have all these parts to the top. On the bottom, square root of 18 times square root of 18 is just 18. Well, here we have 2 of these makes a perfect square, and then these 2 2's make a perfect square. So we have 2 times 3, because that's these 2, and then these 2, and then there's a square root of 3 that's left. Oh, that's a 6. Oh, 6 goes in 18 3 times. Oh, we get the same answer again. So whether you simplify it a different way, or don't simplify it, but at the end simplify it a couple of different times, you end up with the same answer. So you can do them in different ways. You just have to make sure you fully complete it all the way, and then you would get, in this case, that correct answer. Now let's look at a couple of them where there are variables. We're still going to do the exact same concept. This is 8 over the square root of 6x. So I'm simply going to multiply by square root of 6x, because on the bottom that's going to give me a 6 and an x. So square root of 6 times square root of 6 is 6, square root of x times square root of x is x. On the top I'm going to have an 8 over square root of 6x. These can be reduced. 4 goes into both of them. No, 2 goes into both of them, so we have 4 over 3. 4 root 6x over 3x. These, of course, cannot be canceled because that x is inside the square root. So we'd have to have a square root of x here in order to cancel it. So that would be the correct answer for this one. The second one here has a number of different parts to it. There's an easy way, a very easy way right now to cancel it out. So we'll do that, and then we'll do it as if we didn't recognize that easy way. Right now, I'm going to take these as separate ones, because you can do that with square roots. Let's just separate them like that. The 6 is actually square root of 3 times the square root of 2 times the square root of x. Well, these cancel and these cancel. So we have 10 over root 3 multiplied by the same thing, make it a 1 here, and we get 10 times the square root of 3, and that's a 3 on the bottom. By the way, just a thing to be careful of as you're doing these is remember a square root number is not that number. So for instance, this square root of 3 and that 3, you can't cancel these 3's because that looks like a 3, but it's not a 3. The square root of 3 is the number that times itself makes 3. In this case, that's approximately 1.7. So we have here 10 times 1.7. 3 can't cancel with 1.7. So just because you see something that looks like a 3 doesn't mean you can cancel it. When it's in the square root symbol, the radical, when it's in this, that's what this is called, is a radical. When it's inside the radical, it's not a 3. It's the number that times itself makes 3, which is about 1.7. So be very careful with that. Don't make that mistake. And the second thing is, because it's 1.7, you can't like multiply these and come up with a 30, because that's not a 3. So be careful as you're doing these not to get mixed up and accidentally do that sometimes. Now, the next part of doing rationals involves using a conjugate. So here is the concept we're going to have, is that now in the denominator we have a binomial, something plus or minus something, and one of them being a square root. So in this case, 3 minus square root of 5, we're going to need to use the conjugate, which is the same thing but with a different sign. And you do that, the purpose is to make a difference of squares. So we have 3 minus square root of 5, we're going to multiply by 3 plus the square root of 5, and it's this idea that we have a plus b, or a plus b here, and a minus b here, and a times a is a squared, and you have minus ab and plus ab, and minus b squared, and these cancel out. So you'll have a squared minus b squared. So in this case, this would be 3 times 3 is 9, and a negative 5. Square root of 5 times square root of 5 is 5, and would be minus. Now, there is the middle terms of plus 3 root 5 and minus 3 root 5, but those canceled out. So this would come down to a 4. And we are going to do that here in this problem. We are going to multiply by the denominator conjugate, which means the same thing but with the plus. So I'll do 3 plus root 5 and 3 plus root 5. And then it's a matter of thinking these as in parentheses and then multiplying. The top, this times this, so we'll have 3 times square root of 2, not a square root of 6 because this is not a square root. But here we'll multiply these and they're both in square root, so square root of 2 times square root of 5 is the square root of 10. On the bottom, 3 times 3 is 9, negative root 5 plus root 5 is 5, 9, or negative 5 now, 9 take away 5 is 4. And that would be our answer. We can't combine these because that's square root of 2 times square root of 5, so there's no perfect square to come out, and these are different, so we can't just put them together. This is an acceptable answer, but a better answer would be to make separate fractions with these. So we have this fraction plus this fraction. But both of these would be considered acceptable answers here. Okay. Now, there is a part to this that, or another one, let's do another one that's the same concept but a little more complicated. On this one, we had a square root on top, or just a single thing on top, so it was just multiply this times this, and then this times this to get those. And then, of course, the denominator. Now let's do one where the top is a little more complicated, and we'll do a square root of 2 again, minus root 10, divided by 4 plus root 6. So what we're going to do here is we're going to multiply by the conjugate. Conjugate is the denominator, but with a different sign. 4 minus root 6, 4 minus root 6. Okay. So what we're looking at here is put parentheses, because now we're going to have multiplying the top and multiplying the bottom. When we do that, I want to go down, or do I want to go across? I think I'll go across first and then come down. So I'm first going to do this. That's 4 root 2. Notice that if I have a combination square root and a non-square root, I put the non-square number in front. That's normal convention in math, and I do want everybody to follow that same normal thing. So doing square root of 2 times 4, although it's mathematically correct, is not normally the conventional way we do it, so I won't accept it that way. You have to put it in this format. Square root of 2 times square root of 6, and it's one is positive, one is minus, so this will be a negative, and that's going to be square root of 12. Oops, I put a 16 when I meant to put a 12. Now that means I can change it later because there's a 4 inside there, so square root of 4 to be 2, and that would go in front. Now I'm going to do this one, minus 4 root 10, and then I'm going to do this one, which is a plus square root of 60. Okay, so let's see what we can do to work with these. On the bottom, it's going to be a little bit different here. Okay. It's going to be a little bit different here. So 4 times 4 is 16. And then minus 4 root 6 plus 4 root 6 cancels out, so it's going to be a negative 6. So now let's work. That means this is going to become a 10. So now let's look at each of these and break some of these down. This one can be broken down, and that one can. So I'm going to have 4 root 2 minus, well, this is actually a 4 times a 3, so that's a 2 root 3. And then the next one is going to be minus 4 root 10. That one can't change because there's no perfect square in it. This one has some perfect squares in it. The square root of 60 is going to have a 6 and a 10, or I can do, actually let's break it down some more. 6 and 10, a 6 is 2 and 3, and a 2 times 5. So here's my 6 times my 10 to make 60, and 2 of them are 2's. So that means I can take a 2 out, so that's 2 square root of 4. So that's actually plus 4 root, and 3 and 5 is 15. So I have 4 root 2 minus 2 root 3 minus 4 root 10 plus 4 root 15. Each of these square roots are different, so they're almost like different variables. That's like 4x minus 2y minus 4z plus 4w. Even though the 4's are the same, that doesn't mean that these are the same. And underneath it, we have a 10. Well, we can actually simplify each of these. This is the kind of place where you put the 10 underneath each one of them. 4 root 2 over 10 minus 2 root 3 over 10 minus 4 root 10 over 10 plus 4 root 15 over 10. And now we can do some canceling. If I can divide both of these by 2, I'm going to get 2 root 2 over 5. 2 goes into 10 5 times, oops, put a minus there, so it's root 3 over 5, minus 2, let's see, these 2's here, so that's going to be just like this. We're going to get a 2 over 5, 2 root 10 over 5, plus again, same thing, 2 root 15 over 5. Now, this is probably the best way to show the answer. It would be acceptable to put these all together, or even here, just divide each one by 2, make that a 5, and that'd be 2, 1, 2, and 2. So we could do that, or we could do this. 2 root 2 minus root 3 minus 2 root 10 plus root 15. Make that neater. And all of that over 5. This is the best answer. This one would be acceptable. This one would not, because you can divide everything here and simplify it. Okay. So that's one of the more complicated ones to get, where you're going to have a binomial on top and a binomial on bottom, and you'll just have a lot of things to do. So you have to just be very careful, sort of meticulous in making sure that you don't at any point miss one of them. Okay. And there was a practice paper I was looking for. So there are a couple of practice problems now to do. And I'm going to give you 2 of them to practice, and then you can do it on your own and come back in a moment. Let's do practice. A, square root of 14 over square root of 26. And B, 2 plus square root of 15 over 5 minus square root of 5. So rationalize both of these. You can stop the video for a few moments to do both of them and then come back to it. I will start talking in about 5 seconds when you come back to the video. Okay, so what we're going to do here on this first one, there's no perfect square in here. It's 2 and 13. So I'll just multiply by the square root of 26 for both of them. On the top, now I could multiply these two and get a really large number. This is where it might be easier for me just to figure out what the parts of them are. 14 is made of 2 times 7. 26 is made of 2 times 13. Looks like I'm going to have a perfect 4 here to take out, or a 2 to take out. On the bottom, I'm just going to have 26. So this is where 2 times 2 is 4. The square root of 4 is 2. So I'll 2 square root of. And 7 and 13 are both prime numbers, so there's no perfect square of any combination there. So that's 70 and 21. That's a 91. That's 2 root 91 over 26. And it looks like this can be reduced. So we have the square root of 91 over 13, and that would be the answer for the top one. Now, for the second one, this is where we would multiply by the conjugate. And that was the idea, was to get you to practice doing one with a conjugate. And it's simply the same denominator, but changing the sign. So now, we're going to have a bunch of these. Let's do 2 times 5 is 10. That's going to be plus 2 root 5. Then we're going to have this one, which is plus 5 root 15. And we're going to have this one, which is, 5 times 15 is 50, 75. Okay. Underneath it, 5 times 5 is 25. This one, 5 root 5 minus 5 root 5, that cancels out, so I don't have to write anything. And here I have square root of 5 times square root of 5 is 5, and minus and plus is minus. All right, now let's simplify things. This will be a 20, of course. Let's have 20 plus 2 root 5 plus 5 root 15. 75 is made up of 25 times 3, and 25 is a perfect square. So that's going to be 5 root 3. So square root of 25 is 5, and we'll have 5 times root 3. And on the bottom, it's 20. So here, I'm going to do them as separate fractions. That's 2 root 5 over 20. Plus 5 root 15 over 20 plus 5 root 3 over 20. Well, this of course is 1 over 2. 2 goes into 20 10 times, so we have square root of 5 over 10. 5 goes into 24 times, so it's square root of 15 over 4. 5 goes into 24 again, so it's it's just square root of 3 over 4. That is definitely the best answer here because these are not all the same denominators, so I can't put them together. You could put these together as square root of 15 plus square root of 3 over 4, but you shouldn't. It's best here just to have the separate ones, and this is the final answer for this one.